September, they went to December. I don't mind having waited so far since 4 years. I mean, even if they give it in January, I don't mind. But it is almost on the verge of getting completion. Then we'll get a lot of space to move on. All our directors, especially admin, accounts, all will move there. So scientists and youngsters will get a lot of place to sit. And our campus, as you can see, has beautified than before, thanks to effort of Dr. Regis Srinivas and all. We are utilizing the Swachhata Bharat, and one of the endeavors is in this year, it should be one of the most beautiful campuses in the country one can think of, in terms of neatness, in terms of beautification, everything. And we are going to come up plan for new science block and canteen and guest houses which are there in the pipeline. I hope this year we'll get approval for them. And we also got accreditation from ACSIR. That means our students can do PhD under ACSIR apart from KUSAT and Kerala universities, so that it provides more opportunities for students to come from other parts to join here. And we are also going to come up with rock, mineral and some paleontological museum here. And I took a suggestion from Professor Sahni. He gave a lot of advices, and I am going to rope in Professor Patnaik, who is Professor Sahni's student and who created such labs, paleontological museums. It's because if you go abroad, many of you might have seen, all earth science departments, if you go there, you will be greeted by dinosaurs and any large-scale features, tectonic features, which will compel general public to get attached to earth science. And in earth science, you have so many things at your disposal to for public outreach. And I wish next time Professor Sahni comes here, he should be greeted by huge tyrannosaur or dinosaur statues standing outside. And it will also appeal to people outside who are going. And I also told Srilash and Dr. Rashmi, we should have a automatic weather monitoring station giving all display units, humidity, your aerosol content outside, so that all general public who are going on this main road, including the governor and chief minister, should stop and see the values. What is the thing? That's what we are aiming in this year. And I am happy to share with all that Indian Academy of Sciences, one of the premier most scientific academies of our country, is going to host their AGM this year in November 13 to 15. It's a huge thing for us because you get topmost scientists from India here, assembling here, and that it will give a lot of impetus to our organization. And I invite Professor Sahni to be there for that AGM. And another most important thing than what I told is, our institute have laid a lot of emphasis in the last year on discipline. My father used to tell me, I don't care how intelligent you are or how good you are. I am more bothered how disciplined you are. Because discipline is something is in our hands. You cannot blame God or somebody for that. So our institute has committed to be highly disciplined in letter and spirit in every aspect. And you all know that any indiscipline will not be tolerated and will take the strictest action which is possible. And so that all people should be aware of it, and you need to cooperate with the system, because unless discipline is there, I believe nothing can be achieved, and whatever achievements we do or we achieve will get nullified because of these aspects. And another thing I want to convey is we should be proud of our institution. Dr. B.P. Radhakrishna, a legendary geologist, he once wrote an article that are we really proud of our institution? You always think of that institute, this institute, but you should see what you have done to your institute. Australian cricket captain Steve Waugh once said, I will die for my country in baggy green cap. That type of feeling you should have. You should contribute to your institute in a real way. It is the place which is providing all of us our bread and butter. You should give back to the institute in a big way. And unless we love our institute and commit, I don't think it cannot be possible. So you need to be very committed to the institute. And that means you should be very punctual, you should be disciplined, and you should enjoy your time here in doing science and in other extracurricular activities also. And before I end my opening remarks, I should profusely thank my secretary, Dr. M. Ravichandran. And actually, I am here due to him. I had another opportunity to go elsewhere, but he assured me that you join Ministry of Earth Science and I extend all support to you. I am only a WhatsApp call away from you. That word itself gave a lot of support to me, and I am extremely thankful to have such a person at the helm, and the entire Ministry of Earth Science, which is supporting me and us in all endeavors. Whatever we ask, they are helping us. Thank you so much to all of them. And finally, I believe any institute can do well only if happiness quotient is very high. You need to be happy. Science is something cannot be forced. I cannot tell you, you do, I want paper. No, it's not the way. You should feel happy. Whether you get paper or not, that is different aspect. You should really enjoy science. You should immerse in science. You should talk to science in the tea table, across tea table. All great theories like plate tectonics were born across the tea table talks. They were not in rooms. They did not originate. That type of environment I want to create here before I leave in next 3 years. So I wish I need for to do that. I need all of your support, and I am with you. Let us take our institute, one of the best in the world. You need to think on a global level. We should not think on an Indian level. A very ideal place where everybody should look forward to come here and work here and carry good memories with them. I think this is what I thought should be shared with you on this new year, and I wish you all the best. And once again, I thank Professor Sahni and his family for taking their time out and to be with us. Thank you very much. Now comes a very pleasant duty of introducing Professor Ashok Sahni to all of you. Professor, as I said before, Professor Ashok Sahni is a legendary geoscientist. I mean, the word itself means everything. I mean, in our generation and my generation before, if you take few handful of scientists who made tremendous impact to science and research and all these things, Professor Sahani's name invariably comes up. He is currently a professor emeritus, Punjab University, Chandigarh. He studied at Lucknow University and he later obtained his PhD in geology from University of Minnesota in United States in 1968. And of course, out of his love for the motherland, he returned back to India, where he served as initially in the faculty of Lucknow University. Then he moved to Punjab University, Chandigarh. Before I continue, I just want to share, Professor Sahani comes from a very erudite, scholarly family. I'll give example. His grandfather, Professor Ruchiram Sahani, was a physicist. He published papers with Ernst Rutherford, who gave the structure of the atom at Cambridge. His father was a renowned geologist who did PhD at Cambridge. His uncle, again a renowned paleontologist or paleobotanist, Birbal Sahni, on whose name the institute, Birbal Sahni Institute of Paleosciences, today as we call, has been established. And his sons, daughters, everybody, you can see they are from highly academic background, scholarly background. I mean, I thought the purpose of sharing is the young people should know the background of the guests as well. It could inspire them and motivate them. That's why I'm sharing these things. So he is a fellow of several prestigious scientific academies and societies, including the World Academy of Sciences in Italy. He is a fellow of Indian Academy of Sciences. He is a fellow of Indian National Science Academy, National Academy of Science, Allahabad. He is Alexander von Humboldt Fellow. He is also a fellow of the Étranger Geological Society, France, Honorary Fellow of United States Society. And he's a ONGC chair professor from 2017 to 2020. He has been associated with several UNESCO IGCP projects as national and international leader. And actually, Professor Sahni, his name is synonymous with vertebrate paleontology in India. He is called the dinosaur man of India because he has made tremendous seminal contributions on dinosaurs, their extinctions, their eggs, which are well known all over the world. If you look at his citation, he has more than 10,000 citations, and he is one of the few Indians who publish papers repeatedly in Nature and Science with only indigenous resources. So that's a great credence of Professor Sahni. And far more important is he groomed 26 students for their PhD, and some of them are also fellows like him, like GVR Prasad, Sunil Bajpai, and Rajiv Patnaik. They themselves are fellows of the academy. That itself shows, I mean, how a mentor should be, and how a mentor should be can be known by the quality of students he or she has produced. And Professor Sahani has few parallels in that aspect. And he has established dinosaur museums, galleries, at several places. He also received INSA DN Wadia Medal for his contribution to earth sciences. And in 2011, he was awarded the prestigious Lifetime Achievement by the Ministry of Mines for National Geoscience Award, Lifetime Award. And our Ministry of Earth Sciences also has bestowed upon him in 2020 the Lifetime Excellence Award. So you are seeing somebody who is a very scholarly person who made tremendous contributions. And apart from that, Professor Sahani is very active in science popularization programs like his father and grandfather. His talks to school students are received with great enthusiasm and a great interest. He must have given so many popular talks to enthused students and about the excitements of science, doing science, and so forth. So, with these few words which come to me, which I could gather, I heartily welcome Professor Sahani, and I think there cannot be a better way to start a new year than having a scholarly person addressing and sharing his thoughts. So, thank you so much, sir, for accepting our invitation, and we all look forward to your deliberation, talk, and deliberation. Thank you so much. Sir, it's all yours. Yeah. Maybe I can make, yeah. Maybe you can do it for me if somebody can. So this is forward. So I can go back. Which one is laser pointer? This one? Yes. No, it's moving. So can somebody do it for me? Yeah. Can forward somebody move this for me? Yes. Greetings, everyone. I wish you from my heart a very happy, healthy, and successful 2026. I thank the director, Dr. Rao, for all his flattering words. And I don't think I need that. I hope I'm audible. Because in an Indian university, we're used to speaking to a large audience in a very vast hall. So I'm pretty sure that the last person can hear me very well. Is that true? Yes. Okay. So I'd like to thank him for the honor that he has done me by inviting me. Kerala is one of my favorite places to be. And this talk, actually, I'm sure that many of you are not really familiar with this topic. Live streaming, the mic is required. Okay, okay. Yes, so that's okay. So I'll wait a second. Yeah. Because I'm strapped with the. Put it here. So I think I'm doubly audible now. So as I was saying, can I have just a laser pointer? So I was saying that the topic of today's lecture, many of you may not be familiar with it. It's a rather out of the way topic. It comes under the general discipline of biomineralization. That is a subject that deals with the secretion of mineral matter by both animals and plants. So biomineralization is a topic that is not really very, people don't really know much about it. So I thought in this talk, from the vast subjects that I could have talked to you, I would talk to you about this topic. So
So I've entitled it "The Skeletons in Nature's Cupboard: A Biomechanical Approach to Creativity." So most people are not really familiar with how our bodies are built. So we all have skeletons. Dinosaurs have skeletons. Humans have skeletons. Snakes. All vertebrates have got skeletons. But very few people know the mineral matter with which these skeletons are built. And so my talk basically deals with these small nanometer crystallites which are made of hydroxyapatite. In the inorganic world also, you have hydroxyapatites, but these are hydroxyapatites that organisms secrete, and they have completely the same crystal form that you get in the inorganic world. So very few people are aware of this, and the interesting part is that, as you can see, that these crystallites can not only move the pupils, they can move the necks and they can move the faces. Okay, but here you had an animal in which the head was fixed. So what do you think? I'd like to get a answer from the audience here. What do you think is the best thing for this animal to see? What kind of eye should it have so it can see all around it? It's fixed. Anybody? Okay. Uh, Now we can go to the next. So, so, so the one thing that it can do, the one thing that it can do is to build a high curved eye. Okay, on both sides. Because it can't move its head. It can only move. It can only develop its eyesight in a better way, so that it can see at least most of the world around it. And just to tell you, these animals, like vertebrates, were predators, that is, they fed on other trilobites and other animals. Therefore, they required eyesight. And there were other trilobites that were scared of these predators and they needed eyesight to escape the predators. So both the trilobites types, predator and prey, needed eyesight. You can't move around unless you see where you're going. So this is the essential evolutionary trait. And as I said, the way in which the eyesight developed in those days, we still have the same general pattern, even though our lenses have changed. Okay? So you will see in another picture that as evolution increased in trilobites, next please. So just 1 second here. So as I said, each of those rounded lenses is a calcite lens in which the c-axis is coming at perpendicularly out at you, and so you have, this is a typical lens. The refraction index in the lens is 1.6, and you have another focusing system which is known as the intra-lenser bowl, slightly rich in Mg, which has another refractive index which is 1.63. And because of this, the trilobites were able to focus in water, in water, very, very sharply. So this kind of structure uh, was rediscovered by Descartes and all those people about 200 years ago, that they made another lens so that uh, uh, the eye could see very well. You can see this is a 001 plane and all the points are bunched up together, meaning that the c-axis was the dominant axis for each of those crystal, crystallographic lenses. Next, please. So see here, this is this is the way they reacted. So they could not see. So the next best thing was to build high eyes with arcade type of arcade, so that they could look around. The field of view was greatly enlarged. Here, look at that. So, evolution is a peculiar thing, but you can see in front of you how animals and plants react to adverse conditions. Next, please. So here we have even trilobite with periscope eyes. Next, please. So now we come to the second of this. This is something that I've several research papers. This is uh, anyone recognize this? This is rodent incisors, the incisors of rats and mice. This is about the hardest biomaterial known, and it's important to understand why it is the hardest material and how we humans can actually take advantage of the architecture of these teeth to build strong materials, because this is very small. Next, please. Uh, so, enamel, our dental enamel has many functions. So, it can pound on material, it can nip, it can shear like carnivores, cats, wolves, tigers. They have a shearing, and there are ways in which the the evolution has proceeded to stop crack propagation. I'll try and show you this. Next, please. Look here. So, this is enamel, dentine, pulp. So, this is a SEM picture that I took. You can see this is the crack developing, and the developing crack is actually diverted through these other structures, so it cannot proceed straight away. So it's the crack becomes diffuse. So there are a number of ways evolution has stopped cracks in our teeth from getting larger and larger. This is one example. It's the internal structure. And I'll try and explain to you what the internal structure is. Next, please. So, this is again, I find it interesting. This is a skull of a recent rodent. Just look at it. This is the upper incisor and this is the lower incisor. So, they are ever sharpening and ever growing. The tip of the incisor has nanometer crystallites pointed in the direction of maximum stress. Let me ask you on this, I will wait till I get an answer. That why do you think you have teeth that are ever sharpening? Anybody can answer this question. Why are they pointed all the time? But if the rat or mice is feeding on something, but it's not like that. Anybody? Nobody? So the reason is, and this is very interesting. In fact, the Gurkhas of Nepal developed knew this thing. So the Gurkha kukri is made of two types of metals. One that is very strong and one that is relatively weak. The same thing applies to rodent teeth. So in rodent teeth, the inner side is weak. It's made of a different kind of apatite structure. And the outer side is enamel, which is very hard. So every time a rodent bites on something, there is the enamel weathers less, erodes less than the inner side. And therefore, throughout its life, it doesn't need to go to a shop and, say, sharpen my incisors. It's inbuilt. And as I said, the Gurkha cookery is also based on the same principle that if you have two metals fused together, one slightly less harder than the other, you will always have, or you'll always have this kind of uh, this structure, and therefore you will always have ever sharpening teeth. So uh, these are SEM photographs that I've taken. As you can see, this is the tip here. So you can see that there's a great difference between the crystallites, the crystallites that form on the outside of the enamel and on the inside of the enamel. There's a difference. And that is the point that I was telling you about. And until you have SEM, it was not possible actually to tell these. So, so this is another picture that shows you a little bit about the architecture of the teeth. So you have, these are all apatite, but the orientation of the apatite crystallites is different. So here you have these apatite crystallites that are right angle to these ones, and therefore you have a very, very dense structure, a dense architecture, which is able to provide strength to the teeth. And I said, these are the crystallites. I think I must sit down a little bit. Yeah. So, as I said, as I said, if you look at this picture, the whole tooth is hydroxyapatite, but the orientation of the crystallites is different. Some crystallites are bundled together in what is known as prisms, and they are at right angles to this. And I'll show you, in fact, you can see it here. These are prisms that have been eroded. Just look at that structure. That is the normal structure of a rodent tooth. Next, please. Here you are. The same thing that I was talking to you about. Next, please. So here, look at this. You have a three-dimensional photograph and of the orientation of these apatite crystallites. They go in every which way. They're interwoven, and it is this structure that makes these very microscopic teeth to be so hard. So very few people even bother to know. They know that rodents eat into the tiffin boxes, but they have not gone into the fact why this is so. Next, please. So you may not know or know that our teeth look like this. If you look at any human teeth, just take, if a child has lost its teeth, and you just make a section of it, go to the SEM, you will find that our teeth and teeth of other vertebrates, whether it's a hippo or a, whatever, a dog or whatever, there it's a very complex pattern, and this complex pattern is what actually provides strength to the teeth. And therefore, as I said, enamel is one of the hardest materials that has evolved, and that is the reason for it. Next, please. So see here, see how complicated it is. So that's 100 micrometers. You can see. Next, please. Again, this is from Kashmir, uh, Kareva rodents. Just look at that structure. Next, please. So, so in carnivores, the you have a sharing, sharing motion. That is the upper teeth and the lower teeth. They don't go like this, but they go this way, like a shear. And in 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 animals like the hyena or the dog or or tiger, those bundles that I was telling you about, are actually curved like this, like with folds, so that the maximum amount of density can be achieved. So shearing teeth actually uh, uh, are used for cutting flesh, and this is just to show you that different types of habits have different types of arrangements. Next, please. So coming to the last is the is something again that I've done, and what basically what you get in the fossil record is not this, is the shell here. So in India, we are very fortunate that one of the largest dinosaur nesting sites anywhere in the world happens to be in India, and we have tens of thousands of eggs of dinosaurs, tens of thousands. So, so one of the early works that I did in the 1990s was basically to use scanning electron microscopy to study the the eggshell structure. So, as I told you, vertebrates have uh, phosphate bodies, but the eggs are made of calcium carbonate. So this is basically calcium carbonate. So as I was just trying to tell you, whether you have a chicken egg or a dinosaur egg makes no difference. The structure is the same. Next, please. So these are some eggshell structures from India. Ah, so this is eggs. This is the shell. And as I was telling you, that if you cut a section of this, if you cut a section of this, you will get spherulets, just like you get in the inorganic world, you get spherulets. But these spherulets are different. They're made of calcite, and the calcite that you get in these structures, they're all oriented in this direction. So the c-axis of the major structures of eggshells, which are known as spherulets, are pointed parallel to each other. So if you look, I think those of you who are doing uh, igneous rocks will be familiar with uniaxial interference figures. So you can see that is actually one of these. They all act as a single crystal because all the crystallites are parallel to each other. So this is a uniaxial interference figure here and here. There's one other thing that I'd like you to notice. Do you see these rounded, rounded cavities? So when an egg has an embryo, that embryo is growing. It needs oxygen. Next, please. Okay, next, please. So, uh, so, so, so this is the outside of the eggshell. This is sections that I made. That's what I was saying. This is what the eggshell looks like. It can be about 1.5 millimeters to about 2.5 millimeters. And those rounded structures that I was telling you about are basically air canals, air canals. So the baby was growing here and it needed oxygen. So the shell is so made, so architectured that you have air canals that take the atmospheric oxygen and bring it to the embryo. So many of these. Next, please. Next, please. Here again, I will show you. Just look at this. These are air canals. See, they're perfectly rounded, and a number of them. Because, as I said, the baby has to breathe. Next, please. So here's a SEM photograph. This is a shell of an Indian dinosaur. And as you can see, there are a number of these holes through which oxygen was provided to the growing embryo. Next, please. Well, we have a number of ostriches. They have a different kind of structure. So all the pores, all the air canals are located in one place. But basically, the system is the same. The growing embryo of an ostrich was somewhere here, so it needed air. Next, please. So now another interesting thing that the way in which mother dinosaur laid the eggs. So for spherical eggs, there's no problem. But there are some dinosaurs, especially the carnivorous dinosaurs, that have what are known as bipolar eggs. So they're not circular. And as you know, that the compressive strength along the poles is huge. You can't crush a, a, an object like this by pressing on this side and this side. Whereas it will easily break. It will easily break if you push it from this side to this side. So believe it or not, the some dinosaurs, the carnivorous dinosaurs that had bipolar eggs, laid the eggs like this. So it's very interesting to see how behavior actually was incorporated in the fact of this biomechanical necessity. Next, please. I will leave this and try to end it. Next, please. So this is the last slide. You just mentioned the National Institute of Oceanography. This is an aerial view. So I've been around for a long time, and I've been around for the time when the auditorium was being built. So they had a very good idea. The idea was to build an auditorium that was in the shape of these shells here. These shells are known as cardium from heart. If you look at the shells, they look like a heart. Okay? So the idea was very good that we're going to build an auditorium ceiling that looks like a shell. You believe it or not, they struggled for like 15, 20 years. The whole sometimes the ceiling would crack, it would leak. Because what they were doing, as I said, they thought that scale didn't matter. Scale matters. Okay? You can't upgrade something that is so small and so complex. So if you look at a cardium shell, and you people have must have seen a number of these, they are composed of very intricate calcite crystallites. So finally, they've got this thing straightened out after 20 years by making huge alterations in the auditorium. They've got beams and all kinds of things. So uh, I'd like to thank you for listening to me patiently. And in case you have any questions, please feel free to ask me. You have a question? Yes. Yeah. 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 So they are very different in the sense that in stromatolites, the blue-green algae are actually secreting calcium carbonate, and that calcium carbonate is actually mediated by sedimentation. So it's not an entity by itself. They're just taking the calcium carbonate, carbon dioxide, and making blobs of calcium carbonate. Okay, all done. Thank you very much. Yeah.
Thank you, sir, for that insightful and inspiring lecture, and especially mentioning that how biominerals integrates with that crystal structure and shear mechanics to shape the efficient natural skeleton, and offering insights into both art history and the design principle of the advanced biomaterials. Thank you, sir, once again for your lecture. Now I will request our director, sir, to present a memento to our chief guest as a token of our appreciation. Thank you, sir. Now we move on to another pleasant moment. It's better if- So we now move on to another pleasant moment of today's celebration, the welcome of our newly joined colleague to the NCESS family. And I will request Dr. Mahima to, as a gesture of warm welcome, present a flower bouquet to our newly joined employee, Sri Aim Balu, scientific assistant. He completed his MCA and certified application security analyst, joined NCESS in the last year. I'll request Mr. Balu if he wants to share a few words with us.
Hello. Dear colleagues, Happy New Year and happy birthday to NCESS. And I'm very happy and I'm very thankful to NCESS for giving me a warm and a beautiful welcome today and make this day very special to me. And uh, actually, I worked with many organizations so far. My longest serving period for an organization is around 2-3 years only, and I have worked with very diverse of teams and projects so far. And what my opinion about NSS is, like, NSS is a fine-tuned and very well-running institute under Ministry of Earth Sciences. And my area of expertise is far away from NSS, what the primary area addressed by NSS. So I couldn't speak like a word beyond this, but I would like to share a nice experience I received from NSS. That was happened immediately after the next day after I joined NSS. Honorable Director and my reporting officer Sri Rajesh Srinivas had called me to their rooms and asked me like whether you would need any kind of special aids or assistance in the workspace. That somehow touches me like somewhere, because nobody from the previous organization had like asked me the same question before. So but I am a person like I am used to be alone and independent throughout my life, so I immediately reply them like, no, I don't need any kind of special assistance or aids in the work environment, because if I receive such kind of special assistance, I will be, my competency to be alone and independent will be adversely affected. So I just like I'm very grateful and thankful to the director and my reporting officer for the kind offering of that such kind of special aids. And one more word is like I am very thankful to my immediate colleagues working in both CRZ lab and CGL lab, because they are accepting me with all my pros and cons, and thank you for them to make all my day better. Thank you. And I wish ENSYS to be a pioneer in the field of earth science studies in the coming year. Thank you. Thank you so much.
Thank you, Mr. Balu. Another newly joined employee, Dr. Harita A, Scientific Assistant. She completed her BSc and MSc from Mahatma Gandhi University, Kerala, and she did her PhD from Indian Institute of Space Science and Technology. And topic was spectral, chemical, and isotopic investigation of ultramafic hosted magnesites from southern India, implications for natural CO2 sequestration processes. Please, Harita.
Hello everyone. Wish you all a great new year and a great year ahead. Thank you so much for this welcome. As Balu said, we have joined in last February, and the last 1 year has been very great. And this is my first job experience. So far, I have been a student or a research student or a scholar life I had, but this is my first step in my professional career. And that 1 year has been very great. Being a part of a great team, I am assigned to Soldered Research Group, and most of my work are associated with the newly installed quadrupole ICP-MS and the associated clean chemistry lab. And I got the privilege to be a part of this new instrument, its installation, and the work ahead. So it is really an honor to be a part of an institute which is one among the best in research, especially in geological field, and among one of the best mentor we had, director as well as our group head Thompson sir, and very great group of fellow researchers too. So I look forward for great work and good research in the coming years. Thank you.
Thank you, Harita. We warmly welcome you both to NCESS family and wish you a fulfilling and successful career with the organization. Now we proceed to the certificate distribution ceremony, wherein we take pride in recognizing and honoring the outstanding achievements of our colleague for the calendar year 2025. These accomplishments reflect the scientific excellence, dedication, and national and international recognition earned by NCESS scientists. So first, we will begin with the medal and certificate distribution for the Most Promising Researcher Award, instituted to encourage researchers who have demonstrated exceptional scientific potential, consistency, and innovation. May I request our director and chief guest to kindly present the medal and the certificate. From ACRG Group, I will ask Ms. Shilpa S. Dr. M. Vandana. From EHG Group, Dr. Gayatri. Dr. K. Jesuraja. From Atmospheric Science Group, Mr. R. K. Shumesh. Miss Anusha Andrews. From Marine Science Group, Dr. Ramesh Madhipalli. Dr. S. Kaliraj. Hearty congratulations to all the awardees. We now proceed to the medal and certificate distribution for the High Impactful Paper Award, which recognizes researchers whose publications have made significant scientific impact and visibility. From Solid Earth Research Group, Dr. Orku Roy.
He published in Journal Geophysical Research Solid Earth, right?
From Environmental Hydrology Group, Mr. Badimela Upendra. He published his research work in scientific reports. From Atmospheric Science Group, Mr. Dharmodash Josh. He published his paper in Dynamics of Atmospheric and Ocean Science. And from Marine Science Group, Dr. A. Prajit. He published his paper in Quaternary Science. Congratulations to all the recipients for their outstanding scholarly contribution. Now, another award, that punctuality reflects discipline, commitment, and professionalism. We now recognize employees who have consistently demonstrated punctuality during the calendar year 2025. So, the medal going to Dr. K. Srilash from Environmental Hydrology Group. Miss Anju K.S. from Administration. Mr. Sriraj M.K. from Marine Science Group. We now move on to a special recognition under I Got Karma Yogi initiative, a flagship program of the Government of India under the vision of Mission Karma Yogi. This initiative aims to build a future-ready, efficient, and citizen-centric civil service by promoting continuous learning, capacity building, and professional excellence among government employees. In recognition of outstanding engagement and performance on the iGot Karma Yogi platform, we felicitate the employees who secured the highest score: Mrs. Femi Srinivasan, Miss Liji TM, Miss Neeta Sukumar. We now take pride in recognition the scientist and the research scholar who have successfully submitted their PhD thesis in the year 2025. Mr. Shumit Kumar from Atmospheric Science Group, Mr. Dharmodash Josh from Atmospheric Science Group, Miss Himangshi Gupta, Miss Shilpa S, Mr. Proshenjit Dash. Anju. Okay. Yes, Anju and Femi is with us, so please, I will request Anju. She is getting the award for the punctuality. And Miss Femi Srinivasan. She secured the highest score in iGot Karma Yogi program. We now move on to the another important segment of today's program, recognition of excellence and dedication through various awards instituted by in the calendar year 2025. And I will first I will request our director and our chief guest to congratulate Dr. Orko Roy, Scientist D, Solid Earth Research Group, for receiving the Alexander von Humboldt Postdoctoral Fellowship awarded by Alexander von Humboldt Foundation. Hearty congratulations, Dr. Roy. We now felicitate Dr. K. Srilash, Scientist D, Environmental Hydrology Group, for receiving the Young Hydrologist Award 2023, conferred by the Association of Hydrologists of India, Hyderabad. Congratulations, Dr. Srilash. Now I will request our chief guest to kindly present the certificate to felicitate Professor N.V. Chalapati Rao, our director, for being awarded the prestigious J.C. Bose grant by Anushandhan National Research Foundation, Government of India. No, sir. Only one person, Neeta. I will call Neeta because yeah, she also scored highest mark in the Karma Yogi program. With this, we come to the concluding segment of the 13th Foundation Day celebration of NCESS. I now invite Dr. Thompson to propose the vote of thanks.
Good afternoon and wishing you all a very happy new year. So, respected Director NCESS, distinguished Speaker of the Day, my fellow colleagues of NCESS, it's a great privilege to propose the vote of thanks on this momentous occasion of our Institute's 13th Foundation Day. As you are all aware, for the past 12 years, we have been celebrating this Foundation Day with great enthusiasm. And many of us have been fortunate to listen to some of the visionaries in the Earth System Science discipline to mark those special occasions. Today is not an exception. On this 13th Foundation Day, we are fortunate to have amongst us one of the doyens in the field of geoscience in India, Professor Ashok Sahni. I'm sure you will all agree with me that there is no better way to mark a renewed beginning of this year's Institute's research programs of this year 2026 than to have a keynote address by none other than Professor Ashok Sahani. You know, as director, as already mentioned, is in his welcome address, he's not only as an academician and a researcher, but he has been a great mentor to many outstanding researchers and academicians in the same field. So, on behalf of our institute, I express my deepest gratitude to Professor Sahani for gracing us with his presence today and for delivering the 13th Foundation Day lecture. Thank you, sir, from all of us. I also take this occasion to thank Professor Sahani's family who have accompanied him and hope you are having a great time at Tirunelveli. Thank you. Thank you very much. We are profoundly grateful to our director for his visionary leadership and constant encouragement. And 2025 has been a roller coaster for him too as well. So he had to make some very strong decisions. However, it is very evident that NCESS is on the path to greater heights due to his effective intervention in all spheres of NCESS activities. Thank you, sir. Thank you for your constant support. My sincere thanks also to the group heads, senior scientists, and all other scientific supporting staff and administrative staff for their unwavering support in organizing this event. Thank you. And as you all know, the event of this scale does not happen overnight. I wish to place on record our deep appreciation for the organizing committee, Earth Science Forum, especially Dr. Rudra, Dr. Sneha, and the team led by Dr. Madipalli, student volunteers, technical staff who have worked relentlessly behind the scenes to make this program, to see that everything runs seamlessly. Thank you all. And today's awardees require a special mention. Many thanks to all those who have received the awards. And I am sure that they will be models for others also to emulate. Thank you very much. Finally, I thank our enthusiastic audience and fellow students offline and those who have joined online for your active participation and for making this 13th Foundation Day a success. And as we conclude this session, let us carry forward the spirit of excellence that defines our institution. Thank you once again and wishing you all a very cheerful, productive and healthy new year. Thank you.
Thank you, sir. May I request now everyone present in this auditorium as well as joined in virtually to kindly stand for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
With this, we formally conclude our 13th Foundation Day celebration program. Once again, on behalf of NCESS, I wish you all a very happy, peaceful, and prosperous New Year 2026. May the year ahead be filled with good health, scientific breakthroughs, and continued success. Thank you. Yeah, today from 5:30 p.m. Some cultural events are there, so and followed by dinner. So all are invited for that program as well as dinner.